of guidelines, as well as, more recently, to the adoption of an international convention on ballast water management.
The aim is for all shipping to abide by these regulations by the year 2016.
Among these measures will be ballast water exchange at mid-ocean, or measure with a view to remove, kill, or reduce the effect or impact of harmful organisms carried by ballast water.
For these regulations to work, IMO wanted as many countries as possible to sign up. And to encourage developing countries, the Global Ballast Water Management Project was set up in cooperation with the Global Environment Facility and the United Nations Development Programme. But while promising, these systems may only work for certain types of ship. And this led one company to look for an entirely different solution. This tanker is one of a class of vessels known simply as VLCCs, or Very Large Crude Carriers. At 330 meters long, 60 meters wide, and 30 meters deep, they're the largest mobile man-made objects on Earth. This may appear to be a standard tanker, but it isn't. This vessel is fitted with the prototype of a new system that could revolutionize the way that ships of this size manage their ballast. Tom Allen of the tanker company Vela explains why such a system is necessary.
For us in the tanker industry, ballast water exchange is a big problem. If we had to stop at sea and change ballast water out continually as the voyage progressed, it would cost us hundreds of thousands of dollars. The reason for that is the size of these ships. They transport approximately 300,000 tons of crude oil on each voyage, which means on the ballast voyage, they carry 100,000 tons of ballast water.
Exchanging all this ballast water several times during a journey would take several days. And if every oil tanker had to do it, it could result in an increase in the cost of petrol. Tom Allen is part of a team that's developing a unique approach that might just eliminate the need for mid-ocean exchange and treatment methods.
You know, simple ideas are usually the best ones, and that's what's unique about this system. There are no moving parts. The only thing we need to worry about are these pipeline connections. It's very simple.
The hope is that the system could be fitted simply to most existing tankers. Called the flow-through system, it takes advantage of a unique aspect of oil tanker design.
As with all oil tankers today, this ship is equipped with a double hull. That means there's a void space between the side shell plates that we're looking at and the inner cargo space. That void space is used to carry ballast water. That's the problem, and that's why the flow-through system works, because it's easy for the ballast water to flow through using the motion of the ship and exit from the side of the ship.
On the drawing board, this is how it'll work. Ballast water on double-hulled oil tankers is carried along the sides and bottom of the ship. If a hole is cut in the bows, the idea is that the forward motion of the ship will constantly push new ballast water into the ballast tanks, flushing out the old over the sides. Any marine creatures taken on board in harbour will be flushed out within a matter of hours. But cutting a hole in the bows of an oil tanker is a big step. Before they do this, the team want to test the system using the ship's ballast pumps alone. It's time to flood the dry dock. With 100 million litres of water now in her ballast tanks, scientists go on board to take samples for comparison.
Oh, great.
Then, for the first ever test of this flow-through system, they have to take her out to sea.
Start the ballast flow-through procedure.
As the ship travels forward, water is flushed through the tanks. At intervals throughout the trial, further samples of water from the ballast tanks are taken to see if any harbour water remains.
Okay.
Salt content, acidity and sediment content are measured on board. Then the samples are taken back to the lab to find out whether any of the critical microorganisms from the harbour waters remain. And the first results are looking good. So far, tests show that some sort of flow-through system might be a viable means of exchanging ballast water. And because of the size of these ships, it could lead to a large percentage of the world's ballast water being managed more effectively. Different ships require different solutions, and these are just a few of the ones being looked at. And there's no time to lose.
The impacts of invasive aquatic species are one of the 4 greatest threats to the world's coasts and oceans. The other great impacts are global climate change, overfishing, and marine pollution. And the ballast water and invasive species issue has been identified as perhaps the greatest environmental challenge facing the global shipping industry today.
Progress is being made, but its momentum must be maintained so that shipping can work in harmony with the environment.